Welcome to Wings of Arrow. Today we'll see a problem based on unsymmetrical bending. So come to the first question. A Z section with 12 cm cross 3 cm flanges and 20 cm cross 3 cm wave is subjected to movement mx equals to 10 kN meter and my equals to 10 kN meter. Determine the maximum bending stress. So from here we can draw the figure as appeared in your screen. That is, the flanges is 12 cm cross 3 cm and the wave cross of 20 cross 3 cm and the moment is 10 mx and my. So now first of all we will split the sections in section 1, 2 and 3. After splitting the sections, we will form a table. In the table, we will write display for each elements what is a breadth, what is a depth and what is the area and centroid for each elements. So first let's see the first element. First element is this one. What is the breadth? 12 cross 3 and area 12 into 3 we got 36. Now what is a centroid for this element? We have to take a reference point from here, from here to here. That is, total is 12, so the midpoint will be 12 by 2, so 6. And what is y? Y will be from here this distance to the midpoint of this. So from here to here is your 20 plus 3, 23 plus 1.5. So you get as 24.5. Comes to the 2. We have the B is 3 and the D is 20. So area comes B into D 60. What is X bar? X bar will be from this reference point to this point will be your X bar. So from here to here is your 9 plus 1.5. So you get as 10.5. And what is Y? Here to this midpoint. So how will you get this midpoint? Your total half is 10. This will from here to here will be a 10. Then 10 plus 3 will get 13. And the third element is this one. So you have a B as 12 and D as 3 and the area is 36 centimeter square. And when you find this X bar, you have to find from this end point, reference this point to this point. So your half of this 12 centimeter is 6 and from here to this distance is 9. So 9 plus 6 you get as 15. And Y is from here to here, half of it is 1.5. Now recalling the formula of a centroid for X bar of an entire section. So this is a formula as displayed in your screen. You have the individual formula from the table. Apply the formula and you get that X bar is 10.5 centimeter. Similarly, Y bar, you have a formula like this. When you substitute the values, we get as Y bar equals to 13 centimeter. Now to find a moment of inertia, that is Ixx, Iyy and product moment of inertia, that is Ixy. Now recalling the formula for Ixx for 3 different sections, and we know the B1 D1 cube by 12 plus A1. Using this formula, we substituting the formula in this above equation, we get as Ixx equals to 11576 centimeter power 4. Now what is Iyy? This is the formula of Iyy. Now substituting the values of Iyy, we get as Iyy equals to 2367 centimeter power 4. Similarly, Ixy, this is a formula. Substituting the values, respective value, we get as minus 3726 centimeter power 4. Now in the question they have asked to find the bending stress. So recalling the K method formula, that is sigma B equals to y mx Iyy plus my Ixy minus x mx Ixy plus my Ixx by Ixx Iyy minus I squared xy. Now we know all the values. We know the value of mx, Iy, xy and Ixx. Now substituting the value, we get as sigma b equals to minus 100.67 of y and minus 581.48 of x. Now what is the next question is, what is x and y? This x and y will be the coordinates. Now consider the centroid as shown here. The centroid will be your origin, that is 0 0. That means the distance from this point to this point will be your 13, and from here to here will be your 10.5 distance. So if you are going in the left hand side on the x will be negative, if you are going on the right hand side of x will be positive. If you are going upward, the y value will be positive, and if you are going downward, the y value will be negative. Now using this nature, we are going to find the coordinates of A, B, C, D, E and F. The major 6 points we are going to find. Using the table, I have found this x and y value of each coordinate, and substituting for each coordinate I have applied the bending stress in this general equation, and we got these subsequent values. Here I will tell you we have 6 points. In these 6 points, how we have obtained this x and y value. Now here this is a 0 0 coordinate. I said if you are going to right hand side you will get a positive value, if you go to left hand side you will get a negative of x. Now we have the A on the left hand side. So how far is the distance from here to here is 10.5. It is in the left side, so minus 10.5. Now how much upward from here to here? Total distance is 26. So from here to here the distance will be 13. I've written 13. Similarly, now see A and B lie in the same x coordinates, so minus 10.5. Now how far it is decreased the y distance? 3. So from the previous one just subtract the 3, or you can easily find if it is 13 and this is 23, you can find this distance will be 10. So like how also you can find. And for each coordinate value, suppose x and y, the sigma b will be varying for at each individual points. So you need to apply this coordinate for individual locations. So applying in the point A coordinate, we got as 4.7 into 10 power 3 Newton per centimeter square. Similarly, the B point we got as 5.1 into 10 power 3, and subsequent values are shown in the data in the table. And as per the given question, they asked to find the maximum bending stress. So from here we can obtain the maximum bending stress at the point B, where we have the 5.1 into 10 power 3, and which is in tensile in nature, and that is our answer. Thank you for watching. If you have further inquiry, drop down to the mail wingsofarrow@gmail.com. Thank you for watching, and don't forget to subscribe to my channel for more updates. Take care, stay blessed.